Welcome to the Satellite Foundational course for JPSS. This module is on NUCAPS soundings. I'm Scott Lindstrom from SIMS. What will you learn, or maybe just be reminded of, in this module? That's listed here. I'd also like to acknowledge the help of people listed, and others. NUCAPS is an acronym. NOAA Unique Combined Atmospheric Processing System. It uses data from the United States' NOAA 20 or SUMI-NPP satellites, or from EUMETSAT's METOP A and B. The different instruments that provide data to NUCAPS from the satellites are noted. NUCAPS combines information from both infrared sounders and from microwave sounders. The satellite data used comes from polar orbiters, so it's important to know when the satellite is passing overhead. As you use the data, you'll become aware of when the data are generally available. It doesn't vary much from day to day. There are generally 2 passes overhead per satellite each day in mid-latitudes. There's more if you live in Alaska. The figure on the left shows how things shift from one day to the next. A series of days for NPP orbital paths is shown. The orbital paths shift eastward and are a bit earlier from one day to the next. How do NUCAPS profiles get into AWIPS? At present, NOAA gets data from the Svalbard downlink, and then it is processed as it moves through different computers and systems, and it takes anywhere from 60 to 90 minutes or more for data to get into AWIPS. There are initiatives underway to shorten that by including a downlink at McMurdo Station in Antarctica, for example. If you have access to a direct broadcast antenna, the data latency is far better. It is often less than 30 minutes. Vertical profiles are generated in a 2-step method. First, a regression is run using static coefficients from 4 focus days that generated the best statistical fit between the observations and the vertical profiles on those days. These regressions use data from all infrared and microwave channels. This microwave-infrared regression is used to determine if the scene is clear or not. The subsequent retrieval uses a radiative transfer model to iterate to a solution that minimizes the observation minus calculation value. The calculation is the top of atmospheric radiance spectrum calculated with a radiative transfer model. The observation is top of atmosphere radiance spectrum. Initially, this is computed using the regression output. In regions of clouds, where the infrared retrieval typically fails, microwave data can still produce a valid retrieval. Microwave retrievals can fail where precipitation is falling. Not all infrared channels are used in the retrieval. The channels that are chosen are sensitive to only one gas, not multiple gases. In addition, neighboring channels that are highly correlated are not used. NUCAPS vertical profiles are usually smooth and typically have 6 to 10 layers of temperature information and 4 to 6 layers of moisture information in the troposphere. Don't expect to see very thin layers, hot or cold, dry or moist, in the NUCAPS vertical profile. Fields of regard from the CRIS are combined to create a NUCAPS sounding. The figure shows CRIS scan across the VIIRS scene. There are 30 footprints, each containing 9 fields of regard, FORs. One FOR that's cloudy isn't a problem, as long as there is one clear field of regard. This figure also shows that a NUCAPS profile is actually a volume of air, not a single point like a radiosonde. NUCAPS data from just one satellite covers almost all of the mid-latitudes. There are gaps near the equator, and there's overlap near the poles. When you get overlap, you get profiles about 90 minutes apart. What does the data look like in the AWIPS display? That's shown here. The color of the profile location tells you something about the data there. For green dots, both retrievals were successful, and you probably have a reasonable profile to view. If the dot is yellow, then the infrared retrieval failed, but the microwave retrieval was successful. If the dot is red, then both retrievals failed, and the sounding probably won't give you good information. I like to overlay the NUCAPS points on a satellite image, as shown here, so I can anticipate what I'll see. Zooming in on the image, you can see that there's a pretty good spatial correlation between thick clouds and red and yellow sounding locations. Let's look at soundings from 3 locations in close proximity to one another. 2 green and 1 red. Green dot location profiles are smooth but plausible. The profile from the red dot has features that should make you wonder if it's correct. There are lots of soundings. It's important to be able to scan through them quickly to find atmospheric structures that could be important. The way to do that is with pop-up SKUTs. This is something that's selected in the volume browser. Right-click on the image, choose NUCAPS Soundings, and turn on sampling. Then move your mouse over the points and the soundings appear. You should be able to find interesting or noteworthy events. If you find one you want to investigate further, click on the actual point and the N-sharp sounding will appear. If you want a thermodynamic profile, they are readily available from numerical weather prediction sources. The NAM-NEST, the WRF, the GFS, why not use those? Well, you can have convective feedback occurring that gives a profile that is not representative of the environment. In addition, models can have timing issues. Convection might be early or late. In this case, over southeast Colorado, wouldn't you rather have something based on observations that is independent of the model data? NUCAPS information is most robust in the mid-troposphere. There are challenges for a satellite to view the surface through an atmosphere that is opaque to radiation at different wavelengths. Thus, it can be necessary to adjust the NUCAPS soundings in the boundary layer so that the lower portion is more in line with observations. It's on the forecaster's shoulders to decide whether or not the NUCAPS boundary layer is representative. Sometimes it is. Here's an example from several years ago. There's a broken cumulus field over the Missouri River Valley, and the GFS is suggesting QPF. What do you think will happen? NUCAPS data on that day could be used as a forecast decision aid. There was a pass shortly after noon. Let's look at the point in eastern Nebraska. Here's the vertical profile from that point. Near surface values in this sounding are near the values observed from the METARs, so adjustment was not necessary. Would you expect convection here? Probably not. And none developed. If you live north of about 40 north, sometimes you will be lucky and receive NUCAPS soundings about 90 minutes apart, as on this day in Pennsylvania. This is handy in convectively threatening situations because you have a good measure of destabilization over those times. The biggest change in these soundings 90 minutes apart might be the change in the inversion strength. This small change on a slight risk day might inform your decision making. This line of convection did produce damaging winds. Here's another example, this time from a high-risk day. Note a couple of things here. There's a dew point gradient across the region, so the NUCAPS profile that you choose with respect to the gradient will be important. Let's look at this point, at the northern edge of the most moist air. This profile did not match nearby surface METARs, so the bottom part of the profile was adjusted in AWIPS. The modified sounding has a surface-based CAPE around 1800 joules per kilogram. You just looked at the profile from the green box. Let's look at the profile to the south in higher dew points. The sounding there is shown with a surface-based CAPE of around 700, but its surface properties do not align with observations, so it should be adjusted. Once modified, the surface-based CAPE exceeds 3000. This should help in your decision making. So how do you adjust soundings? First, you need to be aware of surface observations. Then click on a point to view the sounding there. This sounding does not match the nearby observations of temperature and dew point. So toggle Edit Graph to On. Draggable points appear that you can move around, and once you're satisfied with the result, toggle Edit Graph back to Off. The modified sounding will then have different thermodynamic parameters that should help make your nowcast more accurate. Coming in the future is something that's been tested at the Hazardous Weather Testbed, the automatic adjustment of the NUCAPS soundings in the afternoon to match RTMA analyses. The sounding produced with this adjustment will have a well-mixed boundary layer, so ask yourself as this is done, is that a valid assumption? Other NUCAPS fields include temperature and dew point on pressure levels. These are coming to AWIPS after 2018. There is separate training available for that. NUCAPS soundings are now available in AWIPS, but only with data from SUMI NPP. But coming soon are NUCAPS soundings from NOAA 20, a satellite that also carries the CRIS and ATMS instruments that are on SUMI NPP. In addition, NUCAPS soundings are produced from MEDOP A and MEDOP B, but they do not yet flow in AWIPS. Soundings at many different times are available at high latitudes. In mid-latitudes, the soundings are available at fewer times, but those times are useful. This concludes the Satellite Foundational course for JPSS on NUCAPS soundings. Thanks for listening.